Okay, this video is just on some preliminaries of the binomial theorem. We're going to go over a few formulas and the factorial and maybe do a few problems. But the first thing I want to talk about is Pascal's triangle. And Pascal's triangle is, you've probably seen it before, but basically you start with 1 and then you put 1 on each side. Like this. So you have a little triangle here. Now what you're going to do is put the 1 here. So the outside is always this outside here. Right in here is always going to be 1. Same for this side. It's always going to equal 1. So basically then you add these two. So 1 plus 1 is 2. Then you put on the outside here. Now we're going to start with 1 again. And 1 on the outside here. And now we're going to add 1 plus 2 is 3, 2 plus 1 is 3, and you get 1. Now let's do it again. Put the 1 here and the 1 here, and we're going to add 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and we're going to do it again until I have no more room. You can go on forever. 1 plus 4 is 5. 4 plus 6 is 10. 10, 5. We'll do it one more time. 1, 1. And this is going to be, add this, you get 6, 15, 20, 15, 6, and 1. And you can go on and on and on. So there's Pascal's triangle. Let me take off this triangle, this little line here, right there. Now, this also is useful for factoring because, let me see which side, I'll put on this side. This you can write as a plus b to the 0 power. Anything to the 0 power is 1 and you get 1. This is like a plus b to the first power. This is a plus b squared. This would be a plus b cubed. A plus b to the 4th. A plus b to the 5th. And a plus b to the 6th. Alright? Now, you already know that when you, anything to the 0 power equals 1, so that's easy. Now, if I wrote this out, this would just be what? A plus b. This one would be a squared plus 2ab plus b squared. And this a and b in the middle here is to the 1. This one, let's see if I can squeeze it in here, would be a cubed plus 3a squared b, I can't fit it in, plus 3ab. So we'll do that on the next page. So we'll start on this, and we're going to write all these out. So the next one we have 1, 3, 3, 1. So that's a squared plus 3a, oh, this is cubed, by the way, a squared b plus 3ab squared plus b cubed. This was a plus b cubed. Now, for a plus b to the 4th, we have a to the 4th plus 4a cubed b plus, what do we have? We have 4, 6, and 4 plus 6a squared b squared plus 4, we're going back down, ab cubed plus b to the 4th. Okay, now let's look at what we have here. our powers here all equal to 4, because I could call this b to the first power. So 3 plus 1 is 4. 2 plus 2, these two equal 4. Here's 1, so 1 plus 3 equals 4. So all of these, each term, when you add the powers, they should equal 4. So let's do the next one. The next one, we have a plus b to the 5th. So we're going to have a to the 5th plus 5a to the 4th, b to the 1st, plus 10. Is it 10? Yeah, 2 10s and 2 5s. All right, 10a cubed b squared plus 10a squared b cubed plus 5a to the first b cubed plus, let's do this first, and this is to the 4th, sorry, plus b to the 5th. And technically you could write this as a to the 5th times b to the 0. But b to the 0 is 1. So look what we have here. We're going down for the a's. The a's, we have 5, 4, 3, 2, 1, and then technically we could have a to the 0 here. For the b's, we go up. We have 0, 1, 2, 3, 4, and the last one is 5. And it goes on and on and on. So this is a good way to factor, especially when you have this. And remember, this is not the same as this. Remember, we already know the formula for that. We've used it several times. These are different. Okay. Now, the next thing we're going to learn is the formula. So the formula is n over j. That means n taken j at a time. And basically the formula is n over j equals n factorial over j factorial over n minus j factorial. Okay? So if I have 3, 1, and I tend to do that, it's not a fraction. So if I have, do it if I go 3, 1. Why do I keep doing that? All right, so 3, 1. N is 3 factorial. J is 1 factorial. Then we have 3 minus 1 factorial, which gives me 3 factorial over 1 factorial times 2 factorial. These two always add up to 3. And then you already know how to do this. This is 3 times 2 times 1. This is 2 times 1, so that equals what? 3. All right, let's try another one. Let's try 4 over 2. So that's going to be 4 factorial over 2 factorial times 2 factorial. You can write this as 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. These cancel. We don't care about that 1. 2 goes into 4 2 times. So 2 times 3 equals 6. All right? And then let's do 8 over 7. I'm doing the ones in the example book. So we're going to have 8 factorial over 7 factorial times 1 factorial, which just basically gives you 8. Because remember we did that earlier. You can work that out. All right? So some of the useful formulas that you're going to want, because I don't want to see you using the calculator on this, is n0 equals 1 and n equals 1. We also have n1 equals n and n over n minus 1 equals n. So let me show you some numbers here. So let's take 5 here. So if you have 5, 0, that means that's 5 factorial over 0 factorial times 5 factorial. 0 factorial is just 1, and that equals 1. So this was this one. Now if we have 5 factorial, or 5 over 5, that's 5 factorial over 5 factorial times 0 factorial. And basically, these two just got rearranged. That equals 1. Now let's try 5 and 1. So that would give us 5 factorial over 4 factorial, 1 factorial times 4 factorial. And when you write all that out, you're just going to get 5. Or you can have 5 over 5 minus 1, which is 4, which just reverses the order in the denominator. So you get 4 factorial times 1 factorial, and that's going to give you 5. You want to know this because you don't want to get all dependent on the calculator, and you want to be able to write them down quickly. All right, now we're going to revisit Pascal's triangle again. So we're going to look at Pascal's triangle, and we'll look at it a different way. We're going to have 0, 0, 1, 0, 1, 1. Then we're going to have 2, 0, 2, 1, and 2, 2. Here we're going to have 3, 0. Do you see what I'm doing? 3, 1, 3, 2, and then 3, 3. And I'll do one more. 4, 0, 4, 1, 4, 2, 4, 3, and 4, 4. Now, if we look back at our formulas here, at these two, they all equal 1. We just showed some examples. So, well, first of all, this equals 1. We can talk about that in class. So this equals 1. Really don't want to cross it out, but I will. 1, 1, 1, 1. Also, from this one, we know that this side equals what? 1, 1, 1. And then for the 2 over 1 and 3 over 1 and 4 over 1, that follows this formula, and that just equals n. So we get 2 here, 3, 4, and also the n minus 1. We're going to get 3, 4, and this one you kind of have to work out, but we know that's 6 from Pascal's triangle. So basically, when we expand binomial expressions, we're going to use this notation, and you need to know the simple ones, like these and those. Those you should not have to put in the calculator. All right? Now, we also want to look at basically expanding the binomial. And then I'm going to give you the formula for that. The theorem, binomial theorem, is when you have some x plus a to the n, that equals n over 0 times x to the n, and basically it's a to the 0 plus n1, which is a, well, they have x first. I don't like this. I'm going to change this to a and b. So let me change this to a and b here. A and b. So I'm going to erase this and do it again. Whoops. It's not erasing. So I'm going to do a to the n, a to the 0, it's a to the n, sorry, a to the n, b to the 0. This one's going to be a to the n minus 1, b to the 1. So the b should match this. Okay, plus n 2, let me move this down here, plus n 2, which would be a to the n minus 2, b 2. Let me do another one, n 3, which would be a to the n minus 3, b 3, and so forth. And you're going to get all the way to dot, dot, dot. Let me erase that part. So we can get all the way to plus dot, dot, dot. And we're going to get n over some number equals a to the n, a to the 0, and b to the n. Well, basically, let me rewrite it. It's going to be a to the n minus n and b to the n. And that's what we're going to do when we expand binomials. Okay? All right. Now we're going to start working on the problems on the next video.